No.
This is the ARMv8 processor right here in the Juno, right?
Hi, I'm Qasim. I work for Linaro and in the Android development team. So we have ARM and Linaro Android engineering teams working at Linaro Connect US 2014. So this is ARM Versatile Express development platform. This has an ARMv8 SOC. So this has 2 Cortex A57 cores and 4 Cortex A53 cores with Mali, and this platform is being used for ARMv8 Android development. So I'll walk you through the development team which actually does all the Android development for ARMv8 processor. So first thing I have with me is Kevin, who basically does the first level Android port of AOSP on ARMv8 processor. So Kevin, how has been your experience on Android for port of AOSP on ARMv8 development platform?
It's been interesting. I've started with bringing up AOSP after the first bring up on ARM software models. I've done a first bring up on the Juno board. So it took just a couple of weeks to get started at first without graphics. After we added Mali and 3D graphics.
And you also submit all the patches to Android AOSP?
Most of them we try to, but some patches are kind of dirty hacks and are not very suitable for AOSP.
Yep.
At least for now. But we're hoping to get everything upstream.
So what do you do?
Well, I'm the tech lead for the Android team inside ARM. So we've been essentially starting off with AOSP work, trying to get it ported early on to 64-bit. Google have done a huge amount of the work, but we've been able to help them in a great number of areas. Supplying things like back-end support for 64-bit in ART, supplying Bionic, supplying some of the early kernel patches that were necessary, and since then we've been upstreaming a large amount of code to enable the overall platform to run on 64-bit.
Okay. So this was the ARM team, and we have the Linaro team that works very closely with ARM team for Android development on ARMv8. So I go to Amit Pundir. So after So after Kevin and ARM does the basic AOSP port, so it basically Kevin pulls the AOSP Android, and then he does all the ARM related software development, and then it basically ends up, so a few patches ends up, and then Amit does all the basic AOSP port of Android on the Juno development platform. So Amit, how has been your experience in getting Android booting on ARMv8?
It was a bit easy because majority of the work is being already done by the ARM team. The thing which we did differently was that since we maintain Android port differently, what we do is we do not use system images, we use tarball images. So we have our own set of patches to make that work. Same thing goes with SELinux patches. We have a set of patches which we use to make SELinux work on Android, because we do kind of extensive SELinux testing nowadays, right?
Yeah.
So if you want, I can show you the list of patches. We do publish these list of patches as part of our daily builds. So if you have a Juno platform to hack on, you can just go to our daily builds, see the changes which we have done, take the builds, and boot Android.
So I'll walk you through the release page, and I'll give you more information on how the release page generally looks like. So this is our Linaro build page for Android. So this page basically gives you all the software that is needed for Android development of AOSP on Juno development platform. So you can see like latest in the last previous release, we enabled SELinux by default, and then we also provided Linaro Android NDK. So this is an Android NDK from AOSP, which Linaro has pulled and then built it with Linaro GCC toolchains. This is for developers this is to help developers on the latest AOSP changes that are being done by Google. And we have all the details that is required for developing software for for the Android community. So
how often do you have releases?
So these are more than releases. These are the Android builds that we prepare out of AOSP. So these builds are available to the Android community every month. So every month we pull AOSP and then we test it thoroughly, validate it, and these builds are available to all AOSP community every month.
Can we check what these guys are doing?
Yeah. So
Yeah.
So we have Bero, and Bero does all the Android NDK porting on ARMv8 SOCs. So he can tell you about all the Android NDK stuff that we are doing.
Yeah, hi.
So what are you doing right now?
Right now I'm working on getting the current AOSP master branch on both ARMv7 and ARMv8 to build with Clang again. We've been working on this before, but then kind of interrupted the work on it to do more ARMv8 porting. Now we're resuming it, and in the meantime a couple of things got broken, so we have to fix this again and submit the patches upstream right away.
So what is this?
No, this is just a regular Nexus 7. It's running our latest build, so this is what you'd get if you compiled AOSP from source yourself and added a couple of our modifications.
So you call it 4.4. I mean, what is it based on?
It's based on the AOSP master branch, so it is somewhat more current than the last official release of Android. And this is stuff that will probably go into the next release.
Nice. And so you have a Juno at home, right?
Yes.
And so you have one of these at home, and what do you do with it?
So those things are really useful to obviously to test what we've been doing. Initially, for a couple of months, we've been doing all the development without having access to the hardware. So we had to test it in emulators, and those emulators could be painfully slow. But now those guys are pretty fast. We can see what our work actually looks like. We can see that actually stuff like OpenGL is working. That was just impossible to test on an emulator.
So this guy.
So he's
Hi.
Juan. He works from ARM, so he can explain you on Streamline.
And so you brought the Juno here. What do you do?
Yes. So right now we were running a demo. Is that connected? Oh, good.
Right.
So it's running a game on the Juno board under Android, 64-bit Android.
So this is 64-bit Android. What works?
I guess a lot of things work.
Everything?
Yeah, pretty much.
Well, it's Android with 64-bit support.
This is an AOSP port of Android
Yeah.
for ARMv8.
Right.
You need to.
There you have Android. So do you have the Juno board with the screen also when you do testing?
No, but the Juno board has a regular HDMI connector here, so I just connect it to my regular screen.
And then use keyboard mouse.
Yeah.
Yes.
I can play my Angry Birds on this. So this is very fast.
Very fast. Is it the fastest in the world?
Not really. This is for development purposes only.
All right. What kind of stuff are you doing right here?
Yeah. So we're basically running this tool called Streamline to measure the various performance of what's running on the Juno board.
So what is that?
So these are results that we got from running some workloads. So some events that we're interested in are like GPU events, so like vertex compute, fragments, also some CPU counter events, so clock ticks, instructions retired, loads and stores. And you can basically use this tool to get access to all those counters simultaneously.
So you monitor everything that's going on the chip.
Yeah, pretty much.
What's the connector to kind of like measure that? How does it work?
Oh, well, so Streamline, the GUI part runs on a host computer, which is what these guys are.
So like two big x86 computers there.
Yeah, yeah.
What do they do?
They're mainly just for doing development, compiling and stuff, and also running the tools, running the front end tools.
All right.
Yeah, and then on the actual target, Juno target, we have the Gator, the Streamline collector running.
So what do you do every day?
What do I do every day? Basically, well, right now I'm basically evaluating this tool to help enable it on the Juno platform.
All right. Is it fully working?
With the stuff that we have on it now, yes, pretty much.
All right. So it's fun. It's cool to have hardware, no?
Yeah, definitely. One of the things I'm working on these days, beyond making sure that newer compilers are supported, is the Linaro builds of the Android NDK, which is the native development kit, which is what you use to create Android applications that use languages other than Java.
So on the Android builds that we create, we also at Linaro we also do extensive validation. So I have with me our Android engineer who does the validation here. So he is Amit Kare.
Hey.
Hello.
Hey.
Amit here. I help the Android team in validating the Juno builds.
Yeah.
We do have a lot of tests which we run, as in Bionic. We run CTS. We analyze all the results and
So we analyze all the failures.
yeah, realize all the failures, and all the testing goes on in Lava, which is our automation and validation framework.
So I have with me the engineer from Android team. So he is Yonkin. He does all the SELinux builds. So basically we enable SELinux by default, and he takes care of SELinux builds. So you can explain about SELinux, what we have done so far.
For SELinux, we have enabled it on our Android by default. You can put when you deploy the images to your device or SD card or USB drive, we can put it with the SELinux enabled, and we also run the CTS test for SELinux. There is one failure there, but that's because the CTS test is still under development. That should be passed now.
So the SELinux is like what? Is like you can just boot it on NDK?
No,
how does it work?
SELinux is mainly for the security restrictions that Google has added. So SELinux is basically a Linux feature that Google has pulled it into Android. So, and by default, in the actual products, in the user builds, so it is by default enabled for SELinux nowadays. So before our customers hit or members hit this problem, so we actually enable SELinux in user build, and we test all the CTS and other tests. So if there are any failures, we catch up early and we fix those things and we submit patches to AOSP. So that's Yonkin's job.
What are you doing right now? What's going on here?
Trying to build Juno.
Yeah, I'm flashing
All right.
images.
We already have the release candidates, and
Yeah.
we're trying to flash it.
All right.
So
Cool.
this is all we do for Android development from ARM to Linaro. So a lot of teams and so many engineers working across so many different organizations to bring Android AOSP running on ARMv8 development platforms. So apart from these, like apart from these in 2015, we have set like major goals. We really want to make AOSP build successfully for ARMv8. We are trying to identify many bottlenecks, and we also want to improve performance of Android by optimizing. Like we already have optimized OpenSSL for Neon. We also are optimizing multimedia codecs for ARM using Neon, and then we are also optimizing like all the external Linux components that are present in Android. We are trying to optimize for Neon and ARMv8. So in 2015 we will be doing a lot of such improvements, and then also we are looking at Clang and GCC 5.0. So there will be Linaro builds of Android for GCC 5.0 and Clang shortly. So there will be a lot of software integration that we are doing. So like graphics drivers from ARM are integrated into our Android builds. So to help our members build their products and go to market quickly. So lot of things. Android user space, like with ARMv8, I think there will be a lot of improvements on the memory addressing. Will basically move and give you more memory to access. So that's one of the key advantages. And I think you can check with ARM mainly on all the ARM related improvements that are being added in v8. So some of the improvements that are available in toolchain and other things, maybe Bero can explain you on instructions and other things, but ARM can give you more information on ARMv8 related improvements.
So it's not only more RAM, right?
No. More RAM is one of the very important advantages, obviously, but another key feature that has been added in v8 is more registers. In the ARMv7 world we have 13 general purpose registers, and in the v8 world we have 31.
So the registers are a big deal, or what?
Yes. For those who don't really know about CPUs, registers are essentially very small pieces of memory that are directly in the CPU. Typically they hold 32, 64 or 128 bits of information, but those are what the CPU can directly calculate with. So usually when you tell a CPU to tell you the result of 2 plus 2, first you have to copy those 2's into registers, and then the result will be put into another register, and from there on it goes to regular memory. So having more registers essentially enables you to keep more information directly at the CPU level and just make things faster.
All right.
And another key thing in ARMv8 is that people who are familiar with ARMv7 know that there are 2 instruction sets, which is the ARM instruction set and the thumb instruction set. That is all historical, and in v8 they are unified, so there's really one instruction set that everything uses, and this will again result in optimized code. And there's also a couple of new instructions and floating point instructions like VFP and Neon used to be optional. Now they are mandatory, so people targeting ARMv8 can assume that they will have a reasonable floating point unit. And that again will make life a lot easier for programmers and will in the end result in faster code, even where the 64-bit parts of the CPU aren't even being used.
All right, so before there was confusion when sometimes there was no Neon, sometimes there was Neon and stuff like that?
Yes. I mean, generally there was no confusion because when you take a device, you know whether or not it has Neon instructions, but for a programmer it could sometimes be hard to decide, do I use Neon instructions to make my code 50% faster, or do I need to target older devices that don't have Neon, like a Raspberry Pi or so? Do I have to hand code instructions that would replace Neon for me? And then either you'd end up with less than optimal code, or you'd end up with something that wouldn't work on all devices, or you'd end up with a lot of extra work implementing things twice.
All right, so I'm going to go check out this. This is 32-bit ARM CPU, but what's the difference in between? I mean, if this was 64-bit, would it be much better?
Well, essentially this guy is fast enough for what it currently does, so there's not that much of a point in putting even faster CPUs into those things, but having faster CPUs enables you to do new things that you just wouldn't have expected to do on a tablet before, or
like
on
this
your
one.
phone before.
Should be a 64-bit ARM in here.
Yes, definitely. I mean, one of the things we currently still use x86 devices for is compiling lots of code, because they're simply faster, and compiling the entire Android repository takes a couple of hours even on a fast machine. And for the 64-bit ARM CPU, I don't see why there would be a need to do it on x86, even though that will obviously remain a viable option.
All right, so cool.
One more thing is that probably, given the CPU will be faster at getting things done, it can enter sleep mode earlier, so that might result in better battery use.
All right, so a bunch of things, and it's compiling right here, right?
Yes. So what's going here is I'm waiting for the stuff to compile a lot, so I'm doing two things at the same time. Here we see a build for ARMv7 with Clang that is still running, and here we see a build for ARMv8 with Clang that has already aborted because of this. So there's a file missing, but that should be easy to fix. And then I can tell it to continue, and then this will go on for a while until it hits the next error, or hopefully until it finishes building successfully. And probably at some point this one is going to bring up an error, or at some point this one is going to say, hey, you're done.
All right. So all the errors what do you do? You fix them?
Yeah, that's the idea. I mean, this is essentially adding support for a new compiler. Probably what happened here with the file not being found is that there's a construct checking for some GCC feature, seeing it's not there because we're not actually using GCC in this build, and then trying to include a file that nobody ever bothered to add because GCC was the only compiler they intended to support at that time. So usually the fix will just be to fix a check for the compiler, or to modify some instruction to follow the actual C or C++ standard more closely.
And that you do the whole day and all the time in Switzerland with the Juno board?
A lot of that. I mean, this is essentially just fixing existing builds. We also do a lot of optimizations, like really looking at a continuous piece of code, seeing that can become better, replace some not so optimized code with better code, or we develop a couple of new things, like in the future we might add additional components to the NDK to make it more usable, and we will push them upstream obviously, so they will be available to all users of the NDK.
Cool.